Hello beautiful people and welcome. In today's video we will be going through the IM1 Chapter 3 practice test. Just a reminder, in my class we are testing on this on Monday the 4th. Alright, let's go ahead and get started. Just a reminder, I am human, so if I make a mistake, please let me know where the mistake occurs so that way I may learn from my mistakes. Question number 1, asking us to write the relation as an order pair, table, and mapping. So for the order pairs, you're going to take your inputs and outputs. Remember, your inputs are your X values, and your outputs are your Y values. So in a relation or in a relationship, you have your inputs and your outputs. So -2 is an input and output is -1. Let me bring this closer so you guys can see this a little bit better. There you go. Hopefully that's better. Next we have an input of 0 and output of 0, input of 2 and output of 1, and input of 4, output of 2. Just a reminder, you have to have commas, you have to have parentheses in order for it to count as an ordered pair. Remember, ordered pairs have a relationship with the numbers they are grouping. So -2 has a relationship with -1. For a table, it's kind of like this, just flipped. Here's your inputs, here's your outputs. So we had our input of -2, output of -1, input of 0, output of 0, input of 2, output of 1, and input of 4, output of 2. For the mapping, you're going to draw 2 ovals. We're going to label them X and Y. Remember, your X's are your domains. Your Y's are your range. Your domain is also your inputs. Range are your outputs. So with the mapping does have some rules. The mapping means that you cannot have any repeated numbers. And the order doesn't really matter of where you place it. So you can go straight, you can go write a -2 here, you can go 0 down here, you can go 4 up here, 2 here. I want you to look and see that, hey, we don't have any repeated numbers. 2, 4, 2, 0 are all different numbers. Now for our Y's, again, we can go kind of random. We can go -1 down here, we can go 0 here, 1 and 2. Again, doesn't matter as long as there are no repeated numbers. So 0, 2, 1, and -1 are all different. This is not the mapping. This is random numbers in bubbles. Okay? What makes it the mapping is the line that connects your inputs with your outputs. So we have an input of -2 and an output of 1. That is your mapping. We have an input of 0 and output of 0. That is a mapping. We have an input of 2, output of 1. That is a mapping. And input of 4, output of 2. That is a mapping. Next up, it says state if the relation is discrete or continuous, then state the domain and range, and if the relation is a function. Explain why the relation is a function or not a function. So if we take a look here at our points, and I'm going to highlight them so you guys can see them a little bit better. We have a point here, 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 and here. And I want you to know that they are all disconnected. When a relation or when a graph is disconnected, that means that they are discrete. Connected means continuous. Now for our domain, we're going to list out all possible X values. So domain is our X values, range is our Y. Because it is discrete, we're going to draw squiggly brackets. And going from the left, we're going to figure out what X values do we have. So if I draw a line here through my X of -2, then we have a 1 negative. Now notice I have 2 -1s, but I'm only going to write it one time. Again, with domain and mappings, there are no repeated numbers. Then I keep going on the x-axis. I do have a 1, a positive 1. And then I do have multiple 2's, but I'm only going to write it one time. Then for the range, I'm going to be looking at the y-axis and taking a look at what numbers I have. Notice I'm going from the bottom because we have to go from the smallest numbers. Then I have a negative 1. Ooh. Then we have a positive 1. And we have a positive 2. Now, is this a function? So let's do the explanation before we do the actual answer for if it's a function or not. A function has one input for each output. So what that means is no repeated x values. So if we're looking at our x numbers, and I do have repeated x values. Another thing that we can do, because it is a graph, we can draw vertical lines. I've kind of been doing that. And see if it passes the vertical line test. Now, what we're looking for at a vertical line test is for intersection with that vertical line one time each time. But if you notice what I've circled, we have multiple intersections at -1 and we have multiple intersections at 2. So that means no, not a function, because it does not pass the vertical line test. Okay, it does not pass the vertical line test. All right, let's go ahead and move on. It says graph the following relations, then determine if the relation is a function or not, and explain. So when graphing your points, we're going to go with our x, y, x, y, x, y, x, y, x, y, x, y. Now I'm labeling them because we want the first number to be on the x-axis, second number to be on the y-axis. Then we're going to mark our point. Then we have -5 and 8 all the way up here. Then we have -6 and -1. Oops, -1. Then we have -4 and 3. Then we have +5 and 8. And 2 and 3. Okay, is the relation a function? Yes or no? So let's do that vertical line test one more time. So if I'm drawing a vertical line here, it hits once, it intersects once, this line intersects once, this one time, this one once, this one once, this one once. So because each time I drew a vertical line, there was intersection only one time, that means yes, it is a function. How do we know? It passes the vertical line test. Now for this one, we can use a different explanation. We can take a look at our x values, and what we're looking for is repeated numbers. And so I have -1, -5, -6, -4, 5, and 2. All of those are different numbers. So because all of my numbers are different on the x spots, then that means yes, it is a function. So no repeated x's means yes, function. So either of these explanations would work. Moving forward, determine if the following is a linear. Oh no, there's a question missing here. That's okay, we're going to skip that. So what we're looking for is to determine if something is linear or not. So if it is linear, it should say a linear function. That's a typo. Linear functions will look like a line, And then for the equations, we're looking for no exponents. So nonlinear would have an exponent. Nonlinear would have an x on the bottom. And nonlinear would have things like a square root, cube root, fourth root, a radical. So things like, let's sketch this out really quick. We'll do a quick little mini lesson here because this question is important and will be on the test. So let's say we have a curve like this. Immediately, it's a curve, not a line, not linear. If we have something that has an equation like y equals x squared plus 3x, oops, there it is. We have an exponent, which means nonlinear. But if you have something that does not have an exponent, like, let's see, 3 times x minus 5 plus 2, notice how there is no exponent on here, but it's not in really a linear form. We're trying to figure out, can this be linear or not? We did a test, and that test was, can we rewrite the equation in y equals mx plus b format? So we would then distribute, not on the 2, just inside the parentheses, combine the 2 with the 15, and then because we have y equals mx plus b, this would then prove that this is a linear function. Yes, yes, yeah, linear. Let's keep it at yeah. No, that's going to bother me, so let's do yes. Yes, linear. Okay, and then my apologies for not writing a question there. Things happen. All right, let's move on. For the next one, it's asking us use the rate of change formula to determine if the following is a linear function. So this is basically asking for slope, just in a different way. So for our slope formula, trying to get a pen here, we have y2 minus y1, yes, parentheses are important, over x2 minus x1. You will be tested on the formula. Make sure you have that memorized. And so what it's asking you to do is, we have our domain x's, our inputs, and our range y, our outputs. And we're just trying to find if the slope is the same for all 3, or I guess 2, changes. So we have a negative 4, 2, and 3, negative 5. And I'm going to separate this out. Then we have 3, negative 5, and 4, 2. So we're trying to figure out the rate of change from negative 4 to 3, 2, and negative 5. Then from 3 to 4, and negative 5 to 2. Now it is asking you to use the rate of change formula, so you have to use the slope formula. Label your points x1, y1, x2, y2. And we'll do one at a time. y2 minus y1, x2 minus x1. And so let's type that into the calculator. Again, you have options of how to do this. You can do this all at once, or you can just separate it out with the top numerator and then the denominator bottom. So we have a negative 7 on top. And yes, parentheses are important. Please make sure that when you're typing this into the calculator, you have parentheses in it. All right, so we can simplify this more. Negative 7 divided by 7 is negative 1. So we have a rate of change, slope, m, as negative 1 for the rate of change between those 2 points. So let's do this again. We've got to relabel x1, y1, x2, y2. And we have Oh, I need to write it down before we use a calculator. Y2 minus Y1, X2 minus X1, and we have 2 minus negative 5, which is 7. And then we have 4 minus 3, and that is 1. So if we simplify that, 7 divided by 1 is 7. So then we're going to take a look at the two rate of change. And because they are different, rate of change, so it's different rate of change, that means no, it is not linear. If the slope is the same, then yes, it is linear. Next up, graph the following function. Hint, ask yourself if this is discrete or continuous. So discrete functions are disconnected. Continuous functions are connected. So the way to tell if something is continuous or not is how they give you a domain. Domain are your x values. When you see a domain listed like this, that means for your x values, these are the only numbers that you can use. You can't use any other numbers. Now, if it's not listed at all, or if they just give you parameters, then you can use whatever x's your heart desires. But here, they are listing, so we have to use these values. This space in the middle is for your work. So we have 2 times negative 5 minus 1, and I'm just inputting my x values into my x. 2 times negative 3 minus 1, 2 times negative 1 minus 1, 2 times 1 minus 1, and 2 times 2 minus 1. All I'm doing is I am replacing the x values into my x spot. Now here again, you can use your brain or use a calculator, your choice. 2 times negative 5 minus 1. And that gives us our y values, our output. So my first output is negative 12. Then I'm going to click my calculator up. I'm going to click my calculator over and replace that negative 5 with a negative 3. My output is negative 8. Do that again with a negative 1, which is negative 4. Now here I do need to delete that negative to just have 1, which is 0. And one more for 2, which is 2. So that means I have now created points of inputs and outputs. I'll write them out really quick. You don't need to write out your points. If you can see the relationships, that's fine from a table. So we have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, making sure that I have all of them. All right, so we have a negative 5 and a negative 12. It's all the way down here at the bottom. Remember, this is a disconnected, discrete graph because the domain values are listed. So we have to not connect our points. We got negative 3, negative 8. 1, 2, 3, 4, 5, 6, 7, 8. We got negative 1 and negative 4. 1, 2, 3, 4. 1 and 0. And 2. Oh, that's wrong. Not 2, 0. 2 and 2. Let's fix that really quick. That should be 2 and 2. So even though it looks like it can give you a line, that's fine. That doesn't matter. It is a discrete, so disconnected. Do not connect those points. Number 7, determine if the following scenario is continuous or discrete graph. The cost of, that's a typo, the cost of dance tickets, let's try this again. The cost for dance tickets, I think there's an English typo here. Let's just say dance tickets cost $4. We're going to graph and show the total sale for up to 5 tickets. I apologize for that English typo. Okay, so we have our X tickets, our work, and our price. So we have to ask ourselves, is this continuous or is this discrete? Can we do anything we want or are we limited in what we can sell? Since we're talking about tickets, tickets have a limitation. I can sell no tickets or I can sell up to 5 tickets. What I can't do is sell 1.5 ticket. What I cannot do is sell 2 2/4 of a ticket. What I cannot sell is a ripped up ticket. It won't count. So because we are listing out our tickets, this will be discrete. So if we have 0 tickets, we make $0. If we have 1 ticket, well, 1 ticket costs $4. That is $4. 2 tickets, that means 8. So for the work, what's happening is we're actually going to be multiplying 4 times the amount of tickets. So for us, we had a ticket of 0, which is 4 times 0. Then we had 1 ticket, which is 4 times 1. 2 tickets, which is 4 times 2. So 3 tickets would be 4 times 3. Then we have 4 times 4 and 4 times 5. Now remember, we don't have any more to sell after 5 tickets. So this is what we have. Now I am looking at my graph and thinking maybe I don't have enough space to graph, but we'll try our best. So 0 means 0. 1 means $4. 2 means $8. Oh, that's 6, not 8. There it is. That's better. And then 3 is 12. And I'm going to stop here just because I don't have any more space. But we would have the 416 and 520. All right, moving on. For question number 8, it's giving you a function. H of x is equal to x divided by 5 plus 3, and it is asking you to evaluate. Now there are 2 different styles of questions here for A and B. Notice that we have a 20 on the inside, and notice that we have a 23 on the outside. That matters. When we have something on the inside, that means that when we write out our function, the 20 replaces the x on the inside. If we have it on the outside, then we will replace the entire outside with that number. So what ends up happening, one of them on the inside ends up being a question for the calculator. We're just going to keep this. We don't change this. And then we do a question on the calculator. So 20 divided by 5 plus 3, I get an answer of 7. So it has to be written in this format for your answer. H of 20 is 7. Now on this side, because we're not replacing x, we need to solve for x. So I'm going to subtract 3, which means I have 20 is x over 5. I'm going to multiply by 5. We have division. We need to multiply to undo that. So x is equal to 5 times 20 is 100. And that is our answer. So notice, take a quick moment to notice the difference between the answers. We put 20 inside, we put 23 on the outside. We plugged it into the calculator, we ended up having to solve an equation. Next up, graphing. Graph the following function. For this one here, notice that we have an x, so that means we're going to be going through the x-axis. What number are we going through on the x-axis? We're going through -3. So that means we're going to draw a vertical line going through the x-axis at -3. For the next one, we have the standard form. Now this is where memorization happens. We have to know what format this is in. This is in standard form. For standard form, we're going to, I'm going to shift this up a little bit. We're going to solve for the x and y intercepts to graph. Start out by copying down the equation twice. Then for the x-intercept, we want x, so that means we're going to make y 0. For the y-intercept, we want y, so we're going to make the x 0. So be careful here. Y is 0, x is 0. It's kind of opposite. We want the x, so we make the y 0. We want the y, so we make the x 0. The trick here is to take your finger, cover up let's see if my hand is in the way. There it is, like that. So we're going to cover it up, and so we're left with 2x and 12. If we cover this up, be careful because this one is a negative. So this is gone. And what we're left with is 2x equals 12. And we are going to solve a one-step equation by dividing by whatever number's in front of x. In this case, that is 2. So x is 6. Here, again, this is gone. Bring down the negative. That's one of the mistakes I saw on a previous exam. Divide by -3, divide by -3. Y is then equal to a -4. Now, what did we just solve for? We solved for points on the x-axis, and we solved for points on the y-axis. So for your x-intercept, we have 6, 0 as our point. And for our y-intercept, we have 0, -4. Oops, I need parentheses, as our intercept. Has to be in this format, has to have parentheses, has to be a point. It's not a random number. It is a point on that axis. So let's go for the x-intercept at 6, 0. Here's your x-axis. And on the x-axis, we have a point on 6. Then we have on the y-axis a point at -4. Then we're going to use something straight. So I have a sheet of paper here to connect. If you have a ruler straight edge, that's fine too. I'm going to just try my best here to connect at the intersections. And then I'm definitely using a pencil in case I make a mistake. And you want to draw your line past your points and then give them arrows because domain was not given to us. It is continuous. Moving forward to the next one, this right here, again, you have to memorize your formats to know what you're doing. This is slope-intercept. Form. So slope-intercept, just like it's called, gives you the slope, which is this number here. This is your M, your slope. And then it gives you your y-intercept. So what you're going to do is you're going to start off with your y-intercept. On your y-axis, you're going to find that point of -3. And that is here, and you're going to draw a point. Then you're going to use your slope to go up and over. So slope is 1/2. That means we're going to go up, down, left, right. It doesn't matter if you go up, down. It doesn't matter if you go left, right. What does matter is that at the end, because this is positive, you have an increasing slope. That means we cannot be going downhill. It has to be going uphill because this slope is not negative. So for me, I'm going to go up 1 over 2 to the right, so that way I can have an increasing slope. And I'm going to do that a couple times, up 1 over 2, up 1 over 2, just because it's going to be easier for me to connect. I can also go down 1 over 2, down 1 over 2, down 1 over 2. And then using that sheet of paper that I had, I'm going to try my best to connect all of these points. Again, to the best of my ability, since I don't have a ruler on me right now. Connect past, arrows, and you are done. So you have to know the different styles of equations to know how to use them to graph. All right, moving on. Oh, we already did that side. All right, solve for slope. So there's A and B, so there's two different questions here. Slope, when you're given 2 points, we have to use the rate of change formula, which we used before. y2 minus y1, x2 minus x1. Label your points, x1, y1, x2, y2, and then plug in your values. So y2 is -7, y1 is 5, x2 is 1, and x1 is -2. Again, you have a choice here. You can type this into the calculator all at once. You can separate it out. You can also use your brain. I'm going to choose to use the calculator. So I get -12 on top, and I get 1 minus a -2, which is 3. Simplify. We got -12 divided by 3. Now this does not always give you a whole number. In this case it did. So just be aware that it's not always going to be pretty like this. Now if they give you a graph, it is your choice. If you want to find pretty points and use the formula, I say don't do that. I say let's just count. So for me, I'm going to take a look and notice that I am going downhill. From left to right, I'm going down. So that means I'm going to have a negative slope. Then I'm going to find 2 pretty points. Now the pretty points that I'm talking about are right on the intersection of the grids. It has to be right on it perfect. So for example, if you take a look at 3, notice that line is a little bit above it. That's not a pretty point. But if you look at 5 on the y-axis, look how pretty that is and right on that intersection. So I'm going to mark 5 as one of my points, and then I'm going to follow the line and look for another pretty point. And for me, it does look like this one here is rather perfect. So I'm going to put a dot here. Then I'm going to draw a mini triangle and count how many ups and overs I have. So I have 1, 2, 3 ups. Then I'm going to restart my counting. 1, 2 to the left. So I know that I already determined that my slope is going to be negative because we're going downhill. So when you write out your slope answer, here's M. We know it's going to be negative because it's downhill. How many ups did you do? 3. How many overs did you do? Well, we went 2 to the left. Can you simplify that fraction? Because this is 1 away, 3 and 2 are just 1 away. That means no, this fraction cannot be simplified. To simplify, you can use your calculator or use division. That is your choice. All right, moving on to number 11. Write the equation of the given line in slope-intercept form. This is where you have to have your formulas memorized. What is slope-intercept form? Which form is that? Slope-intercept is y equals mx plus b. So we need 2 pieces of information. We need the slope and we need the y-intercept, which is going to be your b value. To do this, you're going to start off on your y axis, drag down, and you're going to hit a number where your line intersects. So we have a y-intercept at 0, -2. Now I need to find another point so I can count my slope. So this one's, again, pretty. That one's good. And then which one's the other one that's pretty? I think this one's pretty perfect. So how many ups and overs are we doing? 1 up, 1, 2 to the left. And then we have to ask ourselves, is this line increasing or is this line decreasing? So for me, I am going downhill from left to right. So that means we are going downhill, which means negative slope. So to write our slope, we have downhill negative. Oops, you can't see that, sorry. Downhill negative. How many ups did we do? 1. How many overs did we do? 2. Can we simplify this fraction? Notice how we have a 1 and a 2. 2 and 1 are 1 jumps away, so we can't simplify a fraction when it's just one number away. And now we're ready to write our equation. Keep the y, that stays. M was our slope at -1/2. Keep the x, and b was our -2 on the y-axis. This is our equation. I do believe that is, I got excited here. I thought that was our last question. No, we got 2 more. 3 more. Write the equation in point-slope form. Again, different format. Y minus y1 equals m times x minus x1. So they want us to write it in point-slope form and then convert into slope-intercept form. You have to have these formulas memorized. To write it in point-slope form, we do need a point and slope, m is slope, but notice they've given us only 2 points, so that means you have to solve for slope. So to solve for slope, you're going to label your x1, y1, x2, y2. Then you're going to write out your formula. I'm not going to write out the full formula. We've done that a couple times now. We're just going to go right into placing the numbers in the correct spot. y2 minus y1, x2 minus x1. Again, type it into the calculator. We have 4 on top, and we have -3 minus 9. -3 minus 9 is -12. Again, check if you can simplify. I know that 4 goes into 4. I also know that 4 goes into -12. So for us, our simplified slope is 1 over -3. So then we're going to write this in point slope first. We have y minus y1, which is -2, equals m times x minus x1, which was 9. When you have this, you want to simplify any double negative. So here I had a double negative. Let's make that a positive. Y plus 2 is equal to -1/3. X minus 9. This right here, I'm going to put it in a thinking bubble because that is your point slope form. Because after point slope form, it's asking us to convert this into slope intercept form. So I'll separate this out. Write out the equation here. Y plus 2 is equal to -1/3. X minus 9. To do the to do the slope intercept form, we're going to start by distributing that -1/3 onto both numbers. Now you can use a calculator. I'll show you how. We have y. I lost my pencil. Oh, there it is. Y plus 2 is equal to negative 1/3 times x. And now you can use a calculator. When you use a calculator with fractions, you have to use parentheses. So parentheses negative 1/3 times, open, negative 9, close it, and that will give you a positive 3 for your distribution. We need y equals mx plus b, so y needs to be alone. I'm going to subtract 2 on both sides. We have y equals negative 1/3 x. 3 minus 2 is a positive 1. And now we have our slope-intercept form, which is y equals mx plus b, slope-intercept. All right, let's move on one last question. This is your transformations from the graph f to the graph of h. Write the new transformed function. So a couple things are happening here. You have to describe and then you have to write your new function. So for the description, we are looking inside. Inside means opposite. So that means we are going to shift left. Even though it looks like a plus, it's actually a minus. 4. Because it is inside, we're going to replace x. So let's take our original function, f of x, is equal to, let's not write it in a highlighter because that's kind of not good. F of x is equal to 4x plus 2. I'm going to take this x plus 4. I'm going to bring it. I'm going to remove this x, and I'm going to place that x plus 4 in it. So I still have my 4. I still have my plus 2. And now instead of x, I'm writing x plus 4. We do need to simplify. That means distributing that 4. So we have 4x. 4 times 4 is 16 plus 2, one more step, which is 16, 17, 18. And because it wants a new function here, it wants it called h of x. So for a, h of x is equal to 4x plus 18. Remember, inside means replace. Outside means put on the outside. So if we take a look here, let's do our description. We have a 2 on the outside being multiplied. This is called a vertical stretch because it's a big number by 2. And because we have a 1 plus on the outside, we're going to go shift up by 1. Then again, how do we do that? Because we have a 2 and the 1 on the outside, we're going to write out our function. And I'm going to put parentheses around it. And just like we have this 2, I'm going to write the 2. And just like we have this plus 1, I'm going to write the plus 1. Inside means inside, outside means outside. So here, we need to distribute that 2. We have 8x plus 4. We still have that plus 1 that we need to take care of. So we have 8x plus 5 as our new h of x. So for b, we have h of x is equal to 8x plus 5. That is our new transformed function. All right, beautiful people, that is it for your practice test. Thank you so much. If you made it towards the end of the video, thank you. It is a longer video, but I hope you have a great rest of your day.